Take a moment and think about the largest distance you have ever personally traveled. Perhaps it was a flight across an ocean, a long road trip spanning a continent, or even just a walk to the furthest point you could see on a clear day. Feel the memory of that journey, the time it took, the energy it consumed, the sense of accomplishment upon arrival. Now, hold that feeling, a human-scale understanding of distance, and prepare to watch it shatter into cosmic dust. We are about to embark on an investigation that redefines the very concept of far. An engineering detective story where the crime isn't a murder, but the universe's seemingly absolute imprisonment of life. The mystery isn't who did it, but how do we, a species of thinkers and builders, engineer our escape? This is the story of the 93 billion light-year problem, and it is the blueprint for the future of interstellar civilization. The number itself sounds absurd, almost comical in its scale. 93 billion light-years. Let's not let that number simply wash over us as another piece of astronomical trivia. As an engineer, I see numbers not just as measurements, but as specifications for a problem. They are the parameters of the challenge. So what is the true specification of our cosmic prison? A single light year is the distance a particle of light, the fastest known thing in the universe, travels in one full terrestrial year. That's nearly 6 trillion miles, or 10 trillion kilometers. It's a number so large that flying there in our fastest space probe, the Parker Solar Probe, would take roughly 20,000 years. 1 light year. Now multiply that by 93 billion. The result is a distance so profoundly, so incomprehensibly vast that it breaks our language, our intuition, and our imagination. This isn't just a big space. It is a declaration of impossibility from the cosmos itself. The observable universe, this bubble of light and matter with a diameter of 93 billion light years, represents the absolute boundary of everything we can ever hope to see, to touch, or to know directly. Light from beyond this edge has not had enough time in the 13.8 billion year history of the universe to reach us. So we are, in a very real sense, stranded on an island. Our island is not surrounded by water, but by an ever-expanding ocean of space-time that is carrying galaxies away from us faster than the speed of light itself. This is not a technological limitation. It is a fundamental feature of physics. It's a cosmic speed limit imposed by the very fabric of reality. So, when we talk about an interstellar civilization, we are not just talking about building better rockets. We are talking about defying a law that is woven into the DNA of the cosmos. This is why the 93 billion light-year problem is the ultimate engineering challenge. It is a wall built of space-time, reinforced by the constant of light speed, and stretching into an infinity we cannot even measure. From a conventional perspective, the case is closed. The verdict is in. Humanity is, and will forever be, a local phenomenon. A brief, flickering candle in an impossibly large, dark room. But I am not a conventional thinker. I am an engineer, and an engineer's job is to see a wall and ask, what is it made of, and what tools do I need to take it down? This is where our investigation truly begins. The core premise of this channel, the philosophy of the cosmic engineer detective, is that for every seemingly impossible problem, the universe itself often hides the solution in plain sight. We are trained to think with terrestrial limitations. We build with steel and concrete. We power our world with chemical reactions and nuclear fission. We think in terms of years, decades, and centuries. Our engineering is born from the constraints of one planet, one gravity well, one biosphere. But what if the key to solving the problem of cosmic distance is not to be found in our terrestrial toolkit, but in the cosmic one? What if the very forces that seem to imprison us, gravity, space-time, the life cycle of stars, the bizarre rules of the quantum world, are actually the raw materials for a new kind of engineering? An engineering of civilization scale. This is the central thesis of our investigation today. We will not look at the 93 billion light-year distance as a barrier, but as a design parameter. We will approach the expansion of space-time not as a restraining order, but as a potential power source. We will view the cosmos not as an empty void to be traversed, but as a laboratory and a factory filled with exotic materials and unimaginable energies, waiting for a sufficiently advanced engineer to harness them. Our journey will be structured like a true forensic investigation. First, in Phase 1, we will properly examine the prison wall. We will dive deep into the physics of why interstellar, and especially intergalactic, travel seems impossible. We'll confront the tyranny of the rocket equation, the brutal realities of time dilation at relativistic speeds, the hazards of radiation, and the soul-crushing timescale of it all. We must fully respect the scale of the challenge before we can hope to overcome it. We must understand the lock before we can design the key. Then, in Phase 2, we will become cosmic detectives searching for clues. We will scour the universe for physical principles and phenomena that might offer a way out. We'll investigate the strange geometry of space-time proposed by theories like wormholes and warp drives. We'll look at the energy of black holes, the potential of zero-point energy from the vacuum of space itself, and the possibility of manipulating the very dimensions of reality. We are looking for loopholes in the laws of nature, cosmic exceptions to the cosmic rules. In Phase 3, we will have our eureka moment. This is where we connect the clues to the problem. We'll take the theoretical physics from Phase 2 and apply them as engineering principles. How could we theoretically build a machine to bend spacetime? What kind of structure could safely contain and channel the energy of a star? This is where the blueprint begins to take shape, moving from abstract physics to concrete engineering concepts. Finally, in Phase 4, we will unveil the blueprint itself. We will sketch out the grand, multi-generational project of constructing a true interstellar civilization. We will discuss the types of megastructures required, from star-lifting engines to self-replicating probes that carry the seed of human consciousness across the void. We will explore what such a civilization would look like, how it would communicate, and how it would redefine what it means to be human when our species is no longer tied to a single planet or even a single galaxy. This is not science fiction. This is an exercise in possibility. It is a rigorous thought experiment grounded in the known laws of physics and guided by the unwavering principles of engineering. The question we are asking is not, can we do this tomorrow? But does the universe, in its fundamental laws, permit this to be done at all? Because if the answer is yes, then the journey from impossible to inevitable is merely a matter of time, ingenuity, and the relentless spirit of human exploration. The 93 billion light-year problem is not our sentence. It is our invitation. It is the universe challenging us to become what we have the potential to be, a truly cosmic civilization. The investigation starts now. Every great engineering project begins not with a blueprint, but with a problem statement, a clear, unflinching assessment of the obstacles. Before we can dream of building bridges to the stars, we must first walk the perimeter of our prison and inspect the walls, inch by inch. We must understand their material, their thickness, their fundamental architecture. This is Phase 1 of our investigation, a deep, sobering dive into the physics of impossibility. We are here to confront the titans that guard our solar system, the unyielding laws of the universe that have, for all of human history, kept us tethered to this single pale blue dot. The first and perhaps most humbling of these titans is a deceptively simple mathematical formula known as the Tsiolkovsky rocket equation. It is the foundational prayer and curse of all space travel. At its heart, the equation describes the relationship between a rocket's change in velocity, the velocity of its exhaust, and the ratio of its initial mass to its final mass. To put it in an engineer's terms, it tells you how much stuff you have to throw out the back to make your ship go forward. And what it tells us is devastating. Imagine you want to take a single step. Now imagine that to take that step, you must carry on your back the fuel required for it. But that fuel has weight, so to carry the fuel, you need to carry more fuel. And to carry that extra fuel, you need even more fuel. This is the exponential trap of the rocket equation. It creates a cycle of diminishing returns, so severe it borders on the absurd. Let's apply it to an interstellar journey. To reach even a modest percentage of the speed of light, say 10%, which would still mean a 42-year journey to our nearest star, Proxima Centauri, the calculations become monstrous. Using the most efficient chemical propellants we have today, the amount of fuel required would exceed the mass of our entire planet. If we graduate to the most powerful propulsion we can realistically conceive of today, a nuclear fusion rocket, the fuel-to-payload ratio is still crushing. To send a ship the size of a skyscraper to Proxima Centauri, you would need a fuel tank the size of a small moon. The equation is a tyrant. It dictates that for every kilogram of payload, be it a human, a sensor, or a life support system, you must pay a tithe of thousands, or millions, or billions of kilograms of fuel. It renders our conventional understanding of propulsion utterly impotent on a cosmic scale. It is the universe's first great filter, a mathematical wall that says, you can leave your planet, but you cannot leave your star's immediate neighborhood using these primitive methods. But let's assume, for the sake of our investigation, that we are infinitely clever engineers. Suppose we invent a hypothetical engine that solves the fuel mass problem, a perfect engine. Now we face a far more fundamental wall, one not built of mathematics, but of the very nature of mass, energy, and light. We face Einstein's wall, the speed of light. We've all heard that nothing can travel faster than light. But from an engineering perspective, what does this truly mean? It isn't a cosmic speed limit sign that we might one day find a way to ignore. It is a consequence of the most famous equation in history. E equals mc. Energy equals mass times the speed of light squared. This equation is a two-way street. Mass can be converted into immense energy, but energy, when added to a system, also adds mass. As you accelerate a spacecraft, the energy you pump into it, the kinetic energy of its motion, begins to contribute to its overall relativistic mass. The effect is negligible at the speeds of cars, or even our fastest probes. But as you approach the speed of light, this effect spirals out of control. At 87% of the speed of light, your ship's mass has doubled. At 99.5%, it is 10 times its original mass. At 99.99%, it is over 223 times its original mass. Think of what this means for an engineer. You are pushing an object that gets heavier the harder you push it. It's like trying to run through a liquid that transforms into thick tar, then into concrete, then into solid steel the faster you move. To reach the speed of light itself, the energy required would be infinite, because the ship's mass would become infinite. You would need all the energy in the entire universe to accelerate a single atom to the speed of light. This is not a technological hurdle. This is the universe's operating system. It's a fundamental feature, not a bug. We cannot overcome it with a better engine or a stronger material, because the problem is the material itself. The very atoms of our ship, our equipment, and our bodies conspire against us. Their mass swelling to resist any attempt to reach the ultimate velocity. This is a hard stop. It's a barrier that seems absolute, a definitive statement that the universe is, by its very design, too big for us to ever cross in a conventional way. So we can't carry enough fuel, and we can't reach the speed of light. But the universe offers a strange, tantalizing loophole, time dilation. For the crew aboard a relativistic starship, time itself would slow down. A journey to the Andromeda Galaxy 2, 5 million light-years away, could theoretically be experienced in a mere 28 years of ship time. If you could maintain an acceleration of 1 gram, you could cross the known universe within a single human lifetime. On the surface, this sounds like a solution. But from the perspective of a civilization engineer, it is perhaps the most insidious trap of all. Because while those 28 years pass for you, more than 2.5 million years will have passed on Earth. When you arrive at your destination, the world you left behind is gone. The human race may be extinct, or it may have evolved into something unrecognizable. The very concept of home will have evaporated into the deep past. You and your crew would become chronological ghosts, cosmic castaways forever disconnected from your own species. How do you build an interstellar civilization under these conditions? A civilization requires communication, trade, shared culture, and mutual support. Time dilation severs all of these. It isolates every ship, every colony, into its own island time. Imagine a message sent from the first interstellar colony. By the time it reaches Earth, thousands of years have passed. The reply, if one is even sent, will take thousands more to return. It's not a conversation. It's an exchange between historical artifacts. An interstellar civilization built on this principle would not be a cohesive whole, but a scattered collection of lonely outposts that would diverge genetically, culturally, and technologically until they were no longer the same species. Time dilation doesn't build a bridge between stars. It builds a one-way path to eternal isolation. It saves the individual at the cost of the civilization. For a species looking to expand its presence, not just send a few lonely explorers, this is a fatal flaw. Even if we were to accept these staggering challenges of propulsion and time, we must confront the nature of the voyage itself. The space between stars is not the gentle, empty vacuum we often imagine. It is a shooting gallery, a lethal environment of unimaginable hostility. At relativistic speeds, every stray particle becomes a weapon of mass destruction. A single grain of sand, no bigger than a millimeter across, if struck at 99.9% the speed of light, would impact your ship with the kinetic energy of a 100-ton explosion. It would vaporize any known material and obliterate the vessel. And space is filled with far more than just sand. It is permeated by hydrogen atoms. To your ship, traveling at near light speed, this sparse interstellar medium becomes a constant stream of high-energy particle radiation, like facing the beam of a particle accelerator for decades on end. This would not only erode the hull of the ship, but would also flood the interior with deadly secondary radiation, frying electronics and shredding the DNA of any living organism inside. So how do we engineer a solution? A physical shield. To be effective, a shield would need to be meters, perhaps kilometers thick. But this adds immense mass, which throws us right back into the tyrannical grip of the rocket equation. An energy shield, perhaps a powerful magnetic field? The power requirements to generate and sustain a field strong enough to deflect these particles would be astronomical. Again, adding mass in the form of a colossal reactor and its fuel. Every problem we solve creates another, in a cascading series of engineering impossibilities. And finally, we arrive at the most profound and humbling barrier of all, the one that may truly define the ultimate limits of our expansion. The universe itself is expanding, and it is not just expanding, its expansion is accelerating. This isn't like objects moving away from each other in a static space. The very fabric of space-time itself is being created between galaxies. After a certain distance from us, known as the cosmic event horizon, galaxies are being carried away by this expansion of space faster than the speed of light can travel. This means that light from those galaxies will never, ever reach us. They are receding faster than we could ever hope to chase them. What this implies is chilling. There is a finite and shrinking volume of the universe that is physically accessible to us, no matter how advanced our technology becomes. The vast majority of the galaxies we can see in the sky today are already forever beyond our reach. They are ghosts, their light now reaching us from a time when they were closer, but whose present positions are outside our possible future. We are, in effect, living in a universe where the walls are closing in. Our cosmic prison is not static. Its boundaries are shrinking in terms of accessibility. So the 93 billion light-year problem is, in truth, an overstatement of our potential. The real reachable universe is a far smaller domain. This is the ultimate wall. It is not made of matter or energy, but of space-time itself, and it is a one-way barrier. It is the universe telling us that there are fundamental limits, not just to our speed, but to our destiny. This is the true nature of our prison. A cage defined by exponential fuel costs, a relativistic mass barrier, the isolating sentence of time dilation, a lethally hostile environment, and finally, walls of expanding space-time that are actively moving away, forever sealing off the vast majority of creation. This is the case file for the prosecution. The evidence seems overwhelming. The verdict, seemingly, is impossible. In any great investigation, after the crime scene has been thoroughly analyzed and the sheer impossibility of the case has settled in, the detective's real work begins. It is a hunt for clues, for the small inconsistencies, the overlooked details, the subtle loopholes that can unravel the entire conspiracy of circumstance. In Phase 1, we stood in awe of the perfect prison built by the laws of physics. Now, in Phase 2, we put on our detective's hat and begin our search. We are looking for the universe's hidden footnotes, the exceptions to its own rules. Our search takes us to the very edge of theoretical physics, where we find our first, and perhaps most profound, clue: the nature of space-time itself. We tend to think of space as a static, empty stage, a black backdrop upon which the cosmic drama unfolds. We see it as a void to be crossed, a distance to be conquered. But our greatest clue, gifted to us by Einstein's theory of general relativity, is that this is fundamentally wrong. Space-time is not a stage. It is an active participant. It is a dynamic, flexible, malleable fabric. It can be bent, stretched, twisted, and warped by the presence of mass and energy. This is the source of gravity. A star doesn't pull a planet. It creates a deep curve in the fabric of space-time, and the planet simply follows that curve. For a cosmic engineer, this is the most important clue imaginable. It means that the prison bars are not rigid. They are flexible. If we cannot travel through space fast enough, perhaps we can bypass the problem by manipulating the space itself. This leads us to one of the most tantalizing concepts in all of physics, the Einstein-Rosen bridge, more commonly known as a wormhole. The mathematics of general relativity permit its existence. A wormhole is a hypothetical shortcut, a tunnel through the fabric of space-time. Imagine the universe is a giant sheet of paper. To get from one side to the other, you must crawl the entire length. That is conventional travel. But what if you could fold the paper, bringing the start and end points right next to each other, and then poke a hole through them? You could step through that hole, traversing a vast distance in almost no time at all. That is a wormhole. It is not travel faster than light. It is a redefinition of distance. It's a cosmic subway system that bypasses the limitations of the rocket equation and the light speed barrier entirely. A similar, and perhaps more controllable, concept is the Alcubierre drive, or warp drive. This theory envisions a method of encircling a spacecraft in a warp bubble of space-time. This bubble would work by compressing the fabric of space in front of the ship and rapidly expanding the fabric of space behind it. The result is that the bubble, with the ship nestled safely inside, is propelled forward. From the perspective of someone inside the bubble, they are completely stationary. They would feel no acceleration, experience no time dilation, and their mass would not increase. The ship isn't moving through space at all. The space itself is moving, carrying the ship along with it. This is the ultimate engineering loophole. The law says nothing locally can move faster than light. The warp drive obeys this law perfectly. Locally, inside the bubble, nothing is breaking the speed limit. But the bubble itself, propelled by the expansion and contraction of spacetime, could theoretically travel at any arbitrary velocity, crossing galaxies in weeks or months. It's like being a surfer on a wave. The surfer isn't moving faster than the water, but the wave itself carries the surfer across the ocean. This is a paradigm shift in engineering. The problem of interstellar civilization is no longer one of propulsion, of building a better engine to push against the void. It becomes a problem of geometry, of learning how to become sculptors of the cosmic fabric. But this clue, as profound as it is, comes with a catch. A very big catch. The equations that permit wormholes and warp drives all demand the existence of a new, bizarre ingredient. This leads us to our second clue, the mysterious substance that could be the key to unlocking this new engineering: exotic matter and its associated property of negative energy. In our universe, all the matter we know, stars, planets, you, me, has positive mass and positive energy. It curves space-time inward, creating the familiar dips of gravity wells. To create the anti-gravity, pushing out effect needed to prop open a wormhole or expand space-time behind a warp bubble. You need matter with negative mass, or more precisely, a negative energy density. For decades, this was considered a purely theoretical fantasy. But then, our detective work in the quantum world found a trace of its fingerprints. We found the Casimir effect. If you place two uncharged, perfectly parallel plates very close together in a perfect vacuum, they will be pushed together by an invisible force. The explanation is that the empty space of the vacuum is not empty at all. It is a roiling sea of virtual particles popping in and out of existence. The tiny gap between the plates restricts which of these virtual particles can appear, meaning there are fewer particles and therefore less energy between the plates than in the space outside. This energy differential creates a pressure that pushes the plates together. For the first time, we had experimental proof of a region of space having less energy than the vacuum, a real measurable area of negative energy density. This is a monumental clue. It tells us that negative energy isn't a violation of physics. It's a real, albeit fleeting and microscopic, phenomenon. The universe permits its existence. The engineering challenge, then, becomes a materials science problem of the highest order. How do we take this microscopic effect and amplify it? How can we learn to manufacture, stabilize, and store this exotic matter in quantities large enough to sustain a warp bubble or hold open a tunnel through space-time? We don't have the answers yet, but we now know where to look. We are no longer searching for a magical anti-gravity machine. We are investigating the quantum foam, studying the behavior of the vacuum, and looking for ways to engineer the very ground state of reality. The detective has found a potential murder weapon, but it's made of a material we have yet to invent. The existence of this clue, however faint, transforms the problem from impossible to an unsolved engineering challenge. Of course, even if we learn how to create exotic matter, sculpting space-time on a macro scale will require an amount of energy that dwarfs our total planetary consumption. The initial calculations for a stable warp bubble suggested it would require the energy equivalent of the entire mass of Jupiter. This brings us to our third and equally crucial clue. The universe is not energy poor. We are. The cosmos is filled with power sources of unimaginable scale if we are clever enough to build the machinery to tap them. The rocket equation trapped us because it forced us to carry our energy with us. The new paradigm is to live off the land, to harvest energy directly from our cosmic environment. Our first target would be our own star. A Type 2 civilization on the Kardashev scale is defined as one that can harness the total energy output of its host star. Concepts like the Dyson Swarms, megastructure that would enclose an entire star to capture every single watt of its power, move from science fiction to a logical engineering necessity. By lifting matter from the star's surface, we could acquire trillions of tons of fusion fuel. A single star offers more energy in 1 second than humanity has used in its entire history. This is our local power station. But for truly galactic ambitions, we need bigger generators. This leads us to black holes. We think of them as cosmic drains, points of no return. But a rotating black hole is also the universe's most efficient energy storage device. The Penrose process, a theoretically sound mechanism, suggests that we could extract energy from a black hole's rotation. By dropping matter into a region just outside the event horizon called the ergosphere, we can sling it out with more energy than it had going in. This extra energy is stolen directly from the black hole's rotational momentum, slowing its spin by an infinitesimal amount. It's the ultimate cosmic flywheel. A sufficiently advanced civilization could build a power station around a supermassive black hole and harvest enough energy to reshape space-time on a galactic scale. And finally, there is the ultimate power source, the vacuum energy itself. The same quantum foam that gives us the clue of negative energy is also, theoretically, the largest reservoir of energy in the universe. If we could engineer a way to tap into this zero-point energy, to mine the emptiness of space, our energy constraints would vanish entirely. We would have access to a limitless, omnipresent sea of power. These clues space-time manipulation, the existence of negative energy, and cosmic-scale power sources are the foundations of our case. They tell us that while the prison walls of conventional physics are real, the universe has provided us with a theoretical toolkit for a grand escape. We have found the possibility of a key, the exotic material it must be made from, and the cosmic forges needed to power its creation. The task ahead is to move from these disparate clues to a coherent engineering thesis. We must connect these pieces and begin to sketch the blueprint. The investigation has revealed a path. The path is steep, and it leads through territory currently unknown. But for the first time, we can say with engineering certainty that it is not a dead end. Every complex investigation reaches a pivotal moment. A moment when the scattered clues, the contradictory evidence, and the cold, hard facts of the case suddenly snap into focus. It's the moment a detective, staring at a wall covered in maps, photos, and notes, finally sees the pattern. The connections that were invisible before become blindingly obvious, and a coherent theory emerges from the chaos. This is that moment for us. We have stared into the abyss of the 93 billion light-year problem, acknowledging the brutal physics that form our prison. We have scoured the cosmos for clues, for loopholes in the laws of nature. Now, in Phase 3, we make the ingenious connection. We will take the problems and the clues and forge them into a single powerful technical thesis, the engineering foundation upon which an interstellar civilization can be built. Let us first recap the charges against us. The universe, as our prosecutor, has presented 4 seemingly unbreakable laws. The tyranny of the rocket equation, which dictates that carrying our own fuel is an exponential nightmare. The light speed barrier, a fundamental consequence of relativity that imposes an infinite energy cost on reaching the ultimate velocity. The devastating isolation of time dilation, which ensures that even if we could travel near light speed, we would sacrifice our connection to humanity. And finally, the hostile void, a lethal shooting gallery that makes high-speed travel an act of suicide. These are not 4 separate problems. Our investigation reveals they are symptoms of a single flawed engineering premise. Our fundamental mistake has been to think of interstellar expansion as a problem of transportation. We have been trying to solve it by building a better vehicle, a faster ship. We have been trying to build a cosmic car. But you cannot cross an ocean by building a better car. You must build a boat, and you cannot cross a galaxy by building a better rocket. You must build something else entirely. This brings us to the core of our technical thesis, the central revelation of this entire investigation. The challenge of creating an interstellar civilization is not a problem of propulsion, but a problem of infrastructure. We must stop thinking about building ships that conquer the void and start thinking about engineering the void itself to serve us. Our goal is not to build a faster horse, but to build a galactic railroad. This single shift in perspective is the key that unlocks everything. It transforms the 4 insurmountable walls of our prison into 4 solvable engineering challenges. Let's connect the dots, one by one. First, let's take on the twin titans, the rocket equation and the light speed barrier. Our flawed premise was that a ship must carry its own engine and fuel, a paradigm that leads to absurd mass ratios and the relativistic speed limit. Our new infrastructure-based thesis shatters this premise. We will not build ships that generate their own colossal energy. Instead, we will build a network of cosmic power stations. These will be the nodes of our galactic transport system. Using the clues from Phase 2, we can envision the engineering. around stable, main sequence stars. We will construct Dyson Swarms, vast clouds of solar collectors and habitats that capture a significant fraction of the star's energy. These will be our local Type 2 power sources, providing the baseline energy for entire solar systems. For truly immense power, we will seek out the universe's ultimate generators, rotating black holes. Around these, we will build Penrose process collectors, vast orbital rings designed to extract rotational energy, turning these cosmic engines into the central powerhouses for entire galactic sectors. These power stations solve the energy problem, but more importantly, they solve the rocket equation by externalizing the power source. The ship no longer needs a city-sized fuel tank because it is not the source of its own motion. The energy is beamed to it, or more accurately, it is used at the source to power the infrastructure itself. This infrastructure is the Galactic Railroad, a network of stable, traversable pathways through spacetime. Using the immense energy from our stellar and black hole collectors, we will power the creation and manipulation of the exotic matter necessary to engineer spacetime. We will build warp corridors or gateway stations. Imagine a stabilized wormhole. On one end, a station orbiting Earth. On the other, a station orbiting Proxima Centauri, 4.2 light-years away. These stations are not the ships. They are the railway terminals. They are immense engineering projects that, once built, hold open a permanent shortcut through the cosmos. A vessel traveling between them wouldn't need a powerful engine at all. It would need a simple thruster to enter the gateway. The journey, from the perspective of the ship and its crew, would be nearly instantaneous. Alternatively, we could create warp corridors, predefined routes through space where the fabric of spacetime is permanently energized and primed for travel, reducing the energy cost for an individual ship's warp bubble to a manageable level. Think of it like an electrified third rail for a subway train. The train doesn't carry its own power plant. It draws power from the track. Our interstellar ships will draw their propulsive force from the engineered fabric of space itself. This approach doesn't just sidestep the rocket equation. It renders it irrelevant for interstellar travel. It also neatly bypasses the light speed barrier. We are not accelerating matter through space. We are moving a pocket of space. The ultimate speed limit remains unbroken, but we have engineered a way to be on the other side of the galaxy without ever having to approach it. Now, let's look at the third barrier, the insidious trap of time dilation. This was perhaps the most poignant problem, as it threatened to destroy the very idea of a cohesive civilization, turning explorers into lonely ghosts. The infrastructure thesis provides a direct and elegant solution. Because travel via a wormhole is a redefinition of distance, the time taken is near zero. Travel via a warp drive involves no local acceleration for the passengers. They are at rest within their bubble of normal spacetime. In both scenarios, there is no relativistic time dilation. This is a breakthrough of civilizational importance. A journey to a colony 50 light-years away might take a few weeks of ship time, and when the ship arrives, only a few weeks will have passed back on Earth. This means communication is possible. A dialogue can be maintained between worlds. Trade routes can be established. A shared culture can be developed and nurtured. Fleets can be sent to aid a colony in distress, and they will arrive in time to make a difference. The solution to the physics problem of speed becomes the solution to the sociological problem of unity. It ensures that as humanity expands, it remains humanity. We can spread to thousands of worlds and still be a single, interconnected civilization, sharing knowledge, art, and a common destiny. We will have engineered our way out of the prison of relativity, not just physically, but culturally and emotionally. Finally, we must address the fourth barrier, the hostile void. We established that traveling at high speeds through the interstellar medium was akin to flying through a constant nuclear explosion. Any conventional ship would be scoured, irradiated, and ultimately vaporized. Here again, our thesis provides a stunningly elegant solution. The warp bubble, the very mechanism that propels the ship, is also its ultimate shield. The ship inside the bubble is in a pocket of flat, undisturbed spacetime. It is causally separated from the universe outside. A high-velocity dust particle or a hydrogen atom that lies in its path would never strike the hull. It would encounter the leading edge of the bubble, the region of compressed spacetime, and be deflected around it, much like water flowing around the bow of a ship. The vessel itself is not physically interacting with the hostile medium because it is not truly moving through it. It exists in its own private, mobile universe. This ingenious connection means we do not need to solve the impossible materials science problem of building an indestructible shield. The propulsion system is the shield. The solution to getting there fast is also the solution to getting there safely. So here is our technical thesis, laid bare. Our path to the stars is a 4-stage engineering project. Stage 1, energy independence. We must become a Type 2 civilization by harnessing the full power of our home star. This is the down payment for our cosmic ambition. Stage 2, material synthesis. We will invest this stellar-scale energy into fundamental physics research, learning to create and stabilize exotic matter in industrial quantities. This is the invention of our new cosmic concrete. Stage 3, infrastructure construction. We will use this energy and this new matter to build the first leg of the galactic railroad, a permanent, stable wormhole gateway or warp corridor to a nearby star system. This is our golden spike moment. Stage 4, network expansion. With the first link established, expansion becomes exponential. We use the resources of new star systems to build new power stations and new gateways, creating a cascading, self-replicating network of pathways that will eventually span the entire galaxy. This is not a dream of a single, heroic ship venturing into the lonely dark. It is a plan for a methodical, robust, and relentless expansion of civilization itself. We have connected the problems to the clues, and the result is a coherent, actionable engineering grand strategy. We have found our way out. A blueprint is more than a drawing. It is a promise. It is the tangible link between a grand vision and the sweat, steel, and ingenuity required to make it real. In the preceding phases of our investigation, we have taken a seemingly impossible problem, dissected it, found the hidden clues within the laws of physics, and forged them into a coherent technical thesis. We have promised a galactic railroad. Now, in Phase 4, we unroll the blueprint. We will move from the what and the why to the how. This is the practical, step-by-step construction plan for humanity's interstellar future, and a glimpse into the profound legacy it will create. Our grand strategy, as we established, is one of infrastructure first. The project begins not with a ship, but with a power plant. The first line item on our blueprint is the construction of a Dyson Swarm, the engine that will power our entire breakout from the solar system. This is Stage 1, achieving a true Type 2 energy economy. The project will not start with 1,000 astronauts in bulky suits. It will start with a single modest launch. The payload, a new kind of probe, a self-replicating universal constructor, often called a von Neumann probe. Think of it as a seed of industry. We will send this seed to the most resource-rich, energy-poor region of our solar system, the asteroid belt. Upon arrival, the first probe's directive will be simple. Mine asteroids for raw materials iron, nickel, carbon, silicon, and use those materials and the sun's energy to build 2 copies of itself. Those 2 will then build 4. 4 will build 8. It is the power of exponential growth unleashed on an industrial scale. Within a few decades, a single seed will have blossomed into a swarm of millions, then billions, of automated factories. Their primary task will be to construct the 2 key components of our Dyson Swarm: solar collectors and habitats. The collectors will be vast, lightweight mirrors and photovoltaic arrays designed to capture sunlight and beam the energy wirelessly to where it's needed. The habitats will be the command and control centers, housing the artificial intelligences, and eventually, the human engineers who will oversee this monumental project. This swarm will not be a solid shell, which is structurally and gravitationally unstable. Instead, it will be a vast, porous, and ever-growing cloud of independent structures orbiting the sun, a living, breathing power grid for an entire civilization. The completion of the swarm marks the most significant transition in human history. With access to a meaningful fraction of the sun's 400 septillion watts of power, our energy budget becomes effectively limitless. Concepts of energy scarcity will become historical footnotes. This is the power source for Stage 2. Stage 2 is the creation of our new construction material, exotic matter. With the Dyson Swarm providing near-infinite clean energy, we will build the largest scientific instruments in human history. Imagine vast particle accelerators with rings not kilometers, but millions of kilometers in circumference, built in stable Lagrange points. Imagine research stations the size of cities, dedicated to a single purpose, engineering the quantum vacuum. These will be our exotic matter forges. Here, our brightest minds, aided by unfathomably powerful AI, will work to turn the theoretical promise of the Casimir effect into an industrial process. They will learn to manipulate the vacuum, to suppress or amplify the sea of virtual particles, and to create, stabilize, and store macroscopic quantities of negative energy density matter. This will be the most challenging materials science problem ever undertaken, but it is one that our new energy budget makes possible. We are no longer just using the matter of our solar system to build things. We are using its energy to rewrite the rules of what can be built. This exotic matter is the concrete, the steel, the very fabric of our galactic railroad. With our power plant online and our exotic material in production, we begin Stage 3, the construction of the first gateway. This is the golden spike of our interstellar railroad, and it presents a profound challenge. A wormhole has two ends. To build a bridge, you must have workers on both sides of the ravine. This means we must first send a mission to our nearest star, Proxima Centauri, the old-fashioned way. We will build a gateway seeder, the most advanced conventional starship imaginable. It will not be designed for speed. Relativistic travel is too dangerous and isolating. Instead, it will be a world ship, a multi-generational ark. Its journey will take centuries. The crew aboard will live and die in transit, their sacred mission passed down through generations. But they are not colonists in the traditional sense. They are the construction crew for the other side. Their primary cargo will not be people, but a dormant von Neumann probe and the cryopreserved embryos of the future engineering team. Upon arrival at Proxima Centauri, the probe will activate, using the resources of that system to build a receiving Dyson Swarm and the outbound gateway terminal. Back in our Sol system, a twin terminal will be constructed. These terminals will be the largest structures ever created. Vast orbital rings kilometers in diameter, powered by the full might of their respective stars. Then, the great day will arrive. On a coordinated signal, both terminals will activate. Drawing upon the energy of two separate stars, they will pour unimaginable power into their exotic matter cores, puncturing the fabric of space-time at two precisely calibrated points. The two punctures will meet in a higher dimension, and the tunnel between them will be inflated and stabilized by a lining of exotic matter. The first gateway will be open. The journey of centuries will now take seconds. The sacrifice of the first generation of travelers on the world ship will have paid for the instantaneous salvation of all generations to come. They will be the first to walk back through the gateway they helped build, returning to a soul system that is centuries older, but to a humanity that is now, finally, interstellar. This brings us to Stage 4, network expansion and the human legacy. With the first gateway open, the process becomes self-catalyzing. Using the Proxima Centauri link, sending resources and personnel becomes trivial. New gateways can be built with far greater speed. Each new star system becomes another node in a rapidly growing network. The civilization would spread through the galaxy, not like a slow, creeping vine, but like a neural network firing to life. connecting distant points with instantaneous links. So what is the legacy of such a project? What does humanity become when it is no longer confined to a single planet or even a single star system? Firstly, we become an immortal species. The existential risks of asteroid impacts, supervolcanoes, or self-inflicted catastrophes that haunt a single planet civilization vanish. Our species will be distributed across thousands of worlds, ensuring that no single event, no matter how catastrophic, could ever extinguish the flame of human consciousness. Secondly, we would witness a Cambrian explosion of human culture. Each world, with its unique gravity, its unique star, its unique biology, would foster a new kind of human society. And yet, the Gateway Network would keep them all connected, allowing this incredible diversity to be shared, cross-pollinated, and celebrated. We would have high-gravity worlds of stout, strong poets, and low-gravity worlds of slender, graceful dancers, all contributing to a vast, multifaceted human tapestry. With the end of material scarcity and the guarantee of survival, the purpose of our civilization would inevitably shift. We would transition from a civilization of survival to a civilization of inquiry and stewardship. Our grand projects would no longer be about expansion for its own sake, but about understanding the universe. We would become the galaxy's archaeologists, exploring dead worlds for signs of ancient life, seeking answers to the Fermi paradox. Are we alone? We would finally have the means to find out. And perhaps our ultimate legacy would be to become the galaxy's gardeners. If we find that life is rare, we might take it upon ourselves to become its stewards, using our mastery of engineering to terraform barren worlds and seed them with life from Earth, becoming the agents of Genesis. We would transform from a species that takes from its world to a species that gives to the cosmos. This is the final destination of our engineering. The goal was never just to build a bridge. The goal was to become the kind of civilization that builds bridges. A civilization that has overcome its limitations not through conquest, but through understanding. A civilization that has looked at the 93 billion light-year problem and saw not a prison, but a canvas. The blueprint is on the table. The legacy is a star-faring, immortal, and perhaps a truly wise humanity. We began this investigation with a number, 93 billion light-years. A number so vast, it felt less like a measurement and more like a cosmic sentence of solitary confinement. We stood before a series of walls, the tyranny of the rocket equation, the unyielding barrier of light speed, the chronological prison of time dilation, and the lethal emptiness of the void. The case file for humanity's cosmic future seemed open and shut, the verdict a resounding impossible. And yet, the core philosophy of the cosmic engineer, the driving spirit of the detective, is that no wall is ever truly seamless. One must only look close enough to find the cracks. Our investigation has been a journey along that wall, running our fingers along its surface, tapping and listening, searching for a hollow point, a hidden seam, a subtle flaw in its construction. And we found them, not in a way that would shatter the wall, but in a way that revealed it was never a wall to begin with. It was a door, and the universe had left the key right under the mat. Our journey took us from a state of sober reverence for the problem to a state of profound optimism for the solution. In Phase 1, we confronted the brutal physics of our confinement, giving the challenge the respect it deserved. We understood that conventional thinking, the engineering of our terrestrial cradle, was utterly insufficient for the task ahead. Then, in Phase 2, our investigation turned. We became detectives, scouring the most exotic corners of theoretical physics. We found our clues not in bigger engines or better fuels, but in the very fabric of reality itself. We found the malleability of space-time, the theoretical promise of warp drives and wormholes. We uncovered the faint fingerprints of exotic matter in the quantum foam, the potential construction material for our grand project. And we located the universe's own power stations, the blazing hearts of stars, and the spinning dynamos of black holes. These were not just interesting theories. They were the components of a toolkit we never knew we had. The pivotal moment, our eureka in Phase 3, was the connection. It was the realization that the key to unlocking an interstellar civilization was not to build a better ship, but to build a better road. Our technical thesis was born from this paradigm shift. The future of human expansion is a problem of infrastructure. By externalizing the energy source and manipulating space-time itself, we could create a galactic transport network. This single, elegant concept caused the four great walls of our prison to crumble. The rocket equation became irrelevant. The light speed barrier was bypassed. The isolation of time dilation was nullified. The hostile void was rendered harmless. The problems did not need to be solved individually. They were all symptoms of a single flawed perspective. By correcting our perspective, we solved them all at once. And finally, in Phase 4, we unrolled the blueprint. We laid out the methodical, multi-generational plan to first become masters of our own star's energy, to then forge the exotic materials of our new age, to build the first great gateway, and to then expand that network until the Milky Way itself becomes our unified home. So what is the ultimate lesson of this investigation? It is that the greatest barriers we face are often the ones we impose upon ourselves in the limitations of our own imagination. For millennia, we saw the cosmos as a vast, static emptiness separating unreachable points of light. We now understand it as a dynamic, energetic, and ultimately, a traversable medium. We learned that the solution to a problem of cosmic scale must be a solution of cosmic engineering. You cannot solve a galactic problem with a planetary mindset. You must learn to use the forces of the universe as your tools. You don't fight gravity. You use it to slingshot probes to the outer planets. And you won't fight the expansion of space-time. You will use its principles to propel you between galaxies. This is the essence of advanced engineering. It is not the defiance of nature, but the deepest form of collaboration with it. It is the art of asking the universe, "What are your rules?" and then using those very rules to achieve what was once thought to be magic. This journey also redefines the very purpose of engineering. On Earth, we build bridges to connect cities and trade goods. We build power plants to light our homes. We build computers to solve problems. These are noble and necessary pursuits. But cosmic engineering is different. It is engineering in the service of not just survival or comfort, but of legacy and transcendence. Building a Dyson Swarm and a gateway network is a project whose architects will never see its completion. It is a multi-millennial act of faith. It is a promise made by one generation to a distant future generation. It is the ultimate expression of the human desire to be part of a story that is larger than our own individual lives. It is a declaration that the human spirit does not think in terms of years or decades, but in eons. It is a testament to our unique ability to dream, to plan, and to build for a future we will not personally inhabit. Why undertake such a task? Because the same impulse that drove the first hominids to walk over the next hill, the first mariners to sail beyond the sight of land, is still within us. It is the sacred spark of curiosity, the unquenchable thirst to know what lies beyond the horizon. The 93 billion light-year problem is simply the ultimate horizon. This blueprint, this entire investigation, is not a prediction. It is a proof of possibility. It is an argument, grounded in the physics we know, that a star-faring destiny is not forbidden by the laws of nature. The path is there. The tools are, at least in theory, available. The energy is waiting to be harnessed. The only remaining variables are time and will, and the courage to begin a project whose timeline will dwarf the whole of recorded history. We stand today as a very young species on the shore of a cosmic ocean. For now, we can only dip our toes in the water. We send our robotic probes, our eyes and ears, a little way out into the surf. But we look out at that vast expanse, and we know that is where our destiny lies. The 93 billion light-year problem is not a measure of our imprisonment. It is the measure of our potential. It is the universe beckoning to us, challenging us to grow up, to mature into a species worthy of the cosmos we inhabit, to become not just creatures of a planet, but citizens of a galaxy. This is the frontier of cosmic engineering, and it is the enduring legacy of the stars.